morning, good evening, all. Welcome to Data Analytics Colloquium. My name is Carl, and I am the co-host of the colloquium tonight with Professor Peter C.H. Pan. Professor Pan is on his way. He's stuck in traffic, but he's in any time. So tonight we are really privileged and honored to have a very special guest, and we have Professor Arthur Sperling giving a talk title Embedding Regression Models for Context-Specific Description and Inference. Let me use a couple of minutes to first introduce Dr. Sperling and also give you uh, some of his works and also his background. Dr. Sperling is the uh, class of 1987 professor. Let me give you the full title if I get it right. And he is class of 1987 professor of politics, it should be exactly. And he's a full professor at Princeton University. I think a lot of you may have heard about him when he was at NYU, North and New York University. And he is extensively published and in different topics. And I was really impressed by his work and what good is a regression when he presented earlier in Texas. And Dr. Sperling just joined Princeton this semester. Before then, he had taught in Harvard University and also New York University, and he's the chair of the working group on education and training, and also on the university faculty lead for Texas Data under Moore Sloan Grant, and then coordinated Texas Data seminar series, and then he also is a deputy director for of the Center for Data Science. So we cannot find a scholar and speaker with more experience about machine learning and also Texas data models. And tonight we are really honored to have Dr. Sperling to introduce to us a new method and embedded in regression. So before getting started, and I want to let you know that Dr. Sperling's paper or this lecture is related to his paper published in the latest version of American Political Science Association's flagship journal called American Political Science Review 2023. And you can look up his paper in the APSR. Now we have um, Peter just coming aboard, Professor Pan, and let me introduce you, Dr. Sperling, Dr. Pan of NCXU, and this is really a great honor to have Dr. Sperling to come to give a talk to our students in both sides. So before I get started, and Dr. Pan, do you have any word for us?
Yes, well, apologize for running a little bit late. Got caught in the traffic, and it's really my honor. And thank you, Dr. Sperling, and to come aboard this time. And then it's really an honor. And we read through some of your work, and it's really impressive. And then I'm hoping that, no, actually, I'm confident that we're gonna get a lot of insights from you tonight. So, and talk to the audience tonight. I am supposed to say good evening to all in the United States and good morning to all from the Taiwan side. Thank you all for coming to join us. For those old friends, and thank you for coming back. And for those new to this colloquium, and just let me briefly introduce this series to you. DAC, we call this because Carl coined this uh, this colloquium.
DAC.
Yeah, DAC, and I think that's really appropriate. And this is the fourth season of this colloquium. Now we have invited many the top-notch scholars and to share with us the methodology and or any methods that is up to date, and especially for this year, we have a few series. I mean, a few webinar and focus talking about the topics about Texas data. And then we started with Dr. Spurling, and I'm hoping that the audience will benefit from this series, and then enjoy this very up to date and in social computing. So tonight, and I want to welcome you again. This colloquium is sponsored by UTD and the NCHU. So I'm hoping that we will be keep running this series and this colloquium so that so lots of our students can benefit from this. Okay, and I shouldn't take too much time of Arthur's precious time. So why don't we just turn the microphone to Arthur?
Please.
All right. Shall I begin?
Yes.
Okay, thanks so much. Thank you, professors. It's great to be here. It's evening on the East Coast, but hopefully I can be sufficiently energetic that I can tell people about this paper. So yes, so my name's Arthur Spurling. This is, I'm going to present some co-authored work. The original paper was co-authored with Pedro Rodriguez and Brandon Stewart, who's a colleague of mine at Princeton. And then Elisa Versching is a graduate student at NYU. And so we were working together as I was leaving NYU, and we continue to work together on some embeddings projects. So I'll talk a little bit about the work we're doing with her. So this paper, this project is entitled Embedding Regression. And it's all about coming up with models for context specific, and that's going to be very important talking about contexts. Description and inference. And by inference, we mean in some statistical sense, trying to put uncertainty around things that maybe are tricky to do or that we wouldn't otherwise talk about in a statistical context. So let's start with this very general problem of meaning, right? What does it mean to talk about something meaning something? Okay, that's a very deep philosophical question, but we're going to look at some political science examples. So here are just some, stock pictures from both modern and old politics. So over here we have the top left here, we have this is Biden meeting DeSantis. So we have a Republican and Democratic elite here, and potentially they're talking about something like immigration. And we can imagine that the way that Republicans and Democrats understand the term immigration in the United States differs a bit. Maybe one group think about immigrants as being, people who are undocumented. Maybe another group thinks of them as being people for whom that we should be trying to provide a route to citizenship. Obviously it's a hot issue in the United States, and we can imagine people have different understandings of that term. In the middle here, we have an older period in US politics. In particular, this is the very early 1960s, where we see President Kennedy, and he's meeting Prime Minister Macmillan. And what's going to turn out to be interesting is perhaps how two different types of legislators, so that is to say legislators in the United States versus, say, legislators in the UK, they're both using English, and maybe we can do a comparison. We might be very interested in how they understand the term empire over time. How that changes perhaps in the post-war period. We know, for example, that by the 1950s, the UK has basically given up on being a superpower, and it sort of cedes this role to the United States. How did this change language in the two different countries? And then finally, to zoom in on the UK, although the particular example I'm going to talk about is not really UK specific, we might be interested when we talk about meaning in some sense of sentiment. So what do you feel in some affective sense? Do you like it or dislike it? Do you feel joy or discouragement? What do you feel about some concept, some topic like the European Union? And we might be particularly interested in the UK because we know that certainly during my lifetime, many conservative backbenchers, so there's to say, rank and file members of parliament on the conservative side in the UK, were pretty opposed to the EU, and we might want to see, how that feeling changed over time, especially given the recent Brexit referendum. But as I've been talking, it's been ambiguous. What do I mean by meaning? We need to pin things down. We have a sense of what the term might mean, but it's at the moment it hasn't been very scientific, at least as I've been talking about things. So if we turn to linguistics, and this is a quote that you will see in sort of every paper about meaning and about something I'm going to talk about in a second called word embeddings. There's this quote by Firth, this is from some work in the 1950s, where he says, you know, you shall know a word by the company it keeps. What he is intending from this, what he wants us to understand, is that when we see words in a language, the literal, sometimes physical location of that word relative to other words, what words it's used in the context of, is in some sense informative about what that word means. This basic idea, maybe not unique to Firth, but is sometimes taught as what we call the distributional hypothesis. And it has various implications, but one of them is that if two words appear in the same context, and for our purposes, context is going to mean something very specific, and the specific thing it's going to mean is in a window around a word of interest, if two words appear in the same context, they mean the same thing, and maybe the more similar those contexts, the more similar their meaning. This is not the same as inferring meaning. So this is not a paper about being given a word and trying to say, you know, a priori from first principles, this is what this word means. It's about connotations, and it's about how people understand terms and how they use them. In particular, we're going to provide some tools for making inferences across contexts. And a context here could be literally in some text, but it could also be thinking about covariates. So let's compare Republicans to Democrats. Let's compare men to women. Let's compare people who are rich versus people who are poor, so on and so forth. For example, we might observe that Republicans use the term illegal in the context of, and here we might mean very literally, the surrounding words around immigration. Maybe Republicans use illegal in that context, Democrats do not. Of course, that's a stark case. Maybe they mean something different by immigration. That's the type of inference we'd like to make. So what we're doing here, to be clear, is something called we're using something called a structurist account of language. In some ways, it's a very simple account, and it's saying that meanings are different if the distribution of terms around the targets are different. And I'll clarify what I mean by distribution in a minute, and indeed I'll clarify what I mean by a target as well. But the idea is that if I can show that the way that terms are distributed is different, then I can perhaps show that our understandings, your understanding versus my understanding of a term is different. So what are embeddings? I'm not going to spend a lot of time on this, but just a bit of a crash course. So embeddings are everywhere now. So if you have ever worked with a large language model like ChatGPT, if you've worked with a transformer like BERT, embeddings are one of the initial representations of words that they use such that they can produce this human-like text. But what are they literally? So embeddings are just literally values, real valued vectors of numbers. We might have a word that you're interested in, like the word cat in English, and I could give you back a vector of, say, 300 long of numbers, which somehow summarizes in some sense what that word cat means. And maybe each member of that vector, each slot in the vector is a different sense of what the word means. But the way that they're going to be useful, at least have turned out to be useful, is that we can talk about where one vector is relative to another. Where do they come from? Well, typically they come from some sort of problem like in the way I've described here, where we're trying to predict the word that comes next given the word that's come before. Now, in actual practice, this architecture, which is the term that's used, might differ a bit. Sometimes we're trying to predict the next word. Sometimes we're trying to predict the word in between a bunch of words. That part doesn't matter for our purposes today. But just to give you a sense of it, right, we're trying to predict, observe all these words and trying to think about what word would come next. And we want to weight up the ones that would be most plausible. For example, right, we might be interested in, the probability of seeing the word immigration, given we've just seen illegal. And if you, search the internet, this is the type of thing you'll see here. So this particular plot is from an explainer of Word2Vec. It wasn't our explainer. I borrowed it, but the idea is that these are weights from some neural network where we're trying to take some x's, which are the things we're conditioning on, and sort of predict the next word over on the right-hand side there. So here's a simple example just to get some sense of how embeddings work. Imagine we had 3 words here in English, and we're just observing a very large English corpus, so lots of documents, lots of sentences. And I observe a sentence like this: I had a cup of coffee this morning. Okay, here is my target word. I want to understand sort of something about the word coffee. Here is a context. So as I said, it will be a physical set of words around the word of interest. So here I have what would be a 2-word context, or a window of 2. Now in practice, in industrial applications or commercial applications and in academic applications, typically the window will be much larger, but just for the purposes of the demonstration, we'll just say it's 2. And I'm observing words in here. And maybe if I observe coffee always occurs with cup, then I end up thinking or believing or estimating, I guess I should say, that their embeddings are their embedding vectors are relatively close together. So in this case, right, the embedding vector is just in 2 space. Of course, real embedding might be in many, many high dimensions, but the point remains. Then I go on and I read more and more English, and I discover that, okay, cup and tea are often used in the same context. And maybe, in fact, coffee and tea are never used together, but cup and tea are used together all the time. And so I do this and I make this inference that somehow tea is close to cup and tea is close to coffee. And so I'm learning something about the relationship between tea and coffee without having to push any extra knowledge into the problem. So certainly word embeddings are very popular. So if you've come across them before, that's good. If you haven't, here are some of the kind of big papers on word embeddings from the CS literature. So you'll see that none of them are really more than about 10 years old. And this really understates their citations. So, well, for one thing, I think they're much larger now since I put these slides together a few months ago. But in any case, it understates it because these embeddings have turned out to be incredibly important for many commercial applications. And these big LLMs that we see are using embeddings under the hood. You see them in social science too. So just to sort of shout out to some papers that you might come across. There's a nice paper by Kozlowski looking at how embeddings might tell us about class. So we're thinking about something like social class, about how social class might move with respect to cultural artifacts. Emma Rodman has a nice paper in PA. We'll return to her work later. So where the idea is to try and think about how words change in meaning over time. So again, notice this use of the term meaning. People are very excited about this idea that embeddings help us think about meaning, and that's the insight that we want to trade on today. And there's other papers, more applied papers, looking at, say, ideological placement. This is a very nice paper in PA also a few years ago, looking about how you can scale even very difficult parliamentary situations. Rowe and Cochrane looking at the UK and some other places. And it's a very nice paper using embeddings for some sort of auxiliary estimation purpose. Okay, so embeddings are good, actually. So hopefully that was a bit of a crash course, but you have some sense of what an embedding is. Basically, it exists for every word, and that we can get them somehow. But the problem, and where our project comes in, is that although social scientists have certainly used them, we might want to do more with them. So what would we want to do? Well, the main thing that my co-authors and I think that we want to do is think about, model, quantify potentially systematic differences in meaning across groups and time. Of course, we can just write time as another covariate, and hopefully get measures of associated uncertainty. So just to clarify here, we're saying we want to think about ways, systematic ways, that your understanding of a term, those Democrats and Republicans talking about immigration, those UK and US legislators talking about empire, those, well, conservative versus Labour MPs, say, talking about a term, right? How their understandings and use of a term differ, and get measures of associated uncertainty around that, such that we can talk about ways to make statements about statistical significance. So the phrase that we, or the term that we give that general problem is embedding regression. And the reason that we call it embedding regression is that we had in mind when we started something like the following. You would have some embeddings on the left-hand side. That's your dependent variable. And I promise I'll come back to what I mean about having embeddings on the left-hand side in some detail. And on the right-hand side, I've set up, a simple linear regression, except that, X1 and X2 are group memberships. It could be continuous also. And they're doing some sort of predicting, right? So there's some notion that the ith observation has an embedding. And again, that's going to be some effort from us to get that to work. And we're going to regress it on group memberships. So you can imagine saying, do the embeddings for Democrats differ from the embeddings for Republicans? Party membership is this group variable, and that's the problem to be solved. So I'm going to set up the problem in two different ways. It's two different aspects of the same problem. One is a very simple problem for us to solve, and one is a much more complicated problem for us to solve. So we'll start with the simple one, just to get it out of the way. Didn't really take much effort to solve. And then the second one was much harder. So very clearly, if you think about the equation that I just offered, I cannot in general just say, okay, we'll put embeddings on the left-hand side and then just put group membership on the right-hand side. Because the embedding is not a scalar, right? The embedding for a particular person is, or a particular group or whatever it might be, is, of some length, like 300 or something like this. So that's okay, though. What we can do is turn to something like multivariate regression. So as I said, this is a quicker fix. It's not the end of the world. If I just want to get regression coefficients, what I can do is I can treat the y as an n by d matrix. So I have n observations, and the key thing is it has this dimensionality d. So it has this sort of width d, that this might be a width of, say, 300, because each of these is an embedding. So we see this type of technique turn up in other places. We certainly didn't invent it, obviously. You see it turn up in things like psychology, where you're interested in the effect of some treatment, some drug, say, or some intervention on a set of stimuli, how someone is responding to a set of stimuli. So for each individual person, the D is, of some length, and they have this first stimuli, second stimuli, and so on. And we have where D is the dimension of the vector, and we have n such instances of that word in our corpus. So this straight away should begin to clue you in about, the second problem we have, which is that we want an embedding for every time the word occurs. And we'll spend a bit of time on that in a second. So just to clarify again, the setup of our problem, here is some embedding, yi, and it has some length, let's say 300. Starts, as I say, it looks like random numbers. And if you hang around to see some code later, you'll see that, that's sort of what embeddings look like. And this is my y matrix, so it goes from 1 by d to n by d, right? So I've got this big Y emboldened matrix. Each entry is, entry number 1, entry number 2, going down the side. And then I have it's of some d width, right? Because these are long vectors. But the more interesting problem, and which needs a lot more thought and machinery, is the following. So in the previous slides, I kind of waved my hand over a big issue. And the big issue is that I need, hopefully, I would ideally like to be able to embed every single instance of a word. And I want to be very clear about what I'm saying here. I'm not saying I need an embedding for some word like cat. That's easy. I can get those. They exist online. You can download them from the Stanford lab or Google, whatever. All sorts of people have these embeddings. What I need is that every time the word cat is used in a book, in a newspaper, in a speech that someone is giving, I would like an embedding for every single instance of that term, because then I want to take those embeddings and regress them on the covariates that the speaker has, such as being a Democrat, male, old, young, whatever. And this is very difficult. It's very hard to do. So we're going to import some technology from Aurora et al. And they have a key theoretical result in that paper. They say, in principle, it should be the case that if you want an embedding of a particular word, just find the embeddings of the words around it and take their average. So that may sound like it doesn't solve the problem, but it's worth thinking about why it would. So let's take a sentence in like some diaries or something from a member of parliament, and it might say, the debate lasted hours, but finally we voted on the bill and it passed with a large majority. So let's think about trying to put together an embedding, construct an embedding for the word bill, okay? And I mean the word bill specifically right here in this sentence, not the word bill in general in English, not the word bill in all the language of this parliament or something like this. I mean, take this person's sentence and put an embedding for the word bill. So what Aurora et al. Say is that, well, if you could have an embedding for the word voted on the, an embedding for and it, and passed, and you took the average of those, you should be able to get a reasonable embedding for the word bill. Where would we get those other embeddings? Well, maybe we would download those ones, but the point is that taking the average of those embeddings should give us this very highly specific embedding of bill as it occurs in this sentence. Actually, this doesn't quite work, okay? And this is well known not to work, and it needs a bit of a extra machinery. So we turned to some other work done by a colleague of mine with some other colleagues in a paper by Kodak et al. In 2018. What we need to do essentially, and I'll spend a little bit of time on this before showing you, evidence that the technique works or problems with it or not, is we need to downweight the directions of function words. So a problem with taking the average, as suggested on that previous slide, is you end up having a lot of sort of unhelpful words in there, lots of thes and ofs and a's and so on and so forth. So, and other just common words. So what you need to do is multiply by another matrix A, which will help to downweight those function words and sort of push you back towards the original distinctive meaning of the term. So Brandon, my colleague, my co-author, was a co-author on this paper, and they come up with this very nice way to estimate A, and I'll talk about A in a second. It turns out that once you have this matrix, so firstly, it can be done very quickly. It doesn't take very long to estimate from at least if you have a large corpus. And indeed, I'll talk later about the fact that we're trying to produce these for many languages. But the key feature and why this technique is sometimes called a la carte embeddings is that you only need to estimate the matrix once. So this will be a D by D matrix. So say your embeddings are of dimensions 300. You're going to estimate this embedding matrix, this transformation matrix once. And every time you want a new embedding of some new term from your corpus, you're just going to multiply the average by this transformation matrix. So if you like minimization problems, then perhaps it's obvious to you what's going on in this minimization problem, but let me explain it in a little bit of detail for those like me who don't find these things, it's obvious. So we're saying that we want to estimate this transformation matrix A. And so actually on the left-hand side here, notice that we're putting the hat on it to remind us that we're getting an estimate out. And so we're trying to minimize this equation on the right-hand side, find an A, values of this A, such that we can minimize this. So what's going on here? What do we have on the right-hand side? So VW is just the original embedding of some word, or as you see, it's going to be a sum over many words, but of some word from the large corpus. What large corpus would we be using? Well, you could use Wikipedia, you could use Common Crawl, you could use all sorts of things to get that VW. UW is that mean that we talked about. So now we're saying, let's go to our corpus, right? And I'm trying to get this highly specific embedding for the word bill in that sentence. So let's take the mean of those words, the mean of the embeddings of those words, okay? And now I've got my average UW, which we said doesn't quite work. And we said the reason it doesn't quite work is because it's gonna weight up function words too much. So what it's saying is, give me back an A matrix. This minimization problem is saying, give me back an A matrix, which when I multiply it by the averages, gives me embeddings which are as close as possible to the original embeddings. Now that might sound a bit strange, right? The whole point was that we didn't want to use the original embeddings. So why do I want this A matrix that sort of pulls me back towards those original embeddings? So what's happening here is that we don't just want to take the mean of these function words, right? That doesn't seem right. If we see some word like Bill and it was surrounded by of and the and so on and so forth, I don't just want to take means and that's the new embedding. What I want to do is prevent that from happening. And the A matrix is helping to prevent that. It's forcing this average to not depart too much from the original learned embeddings on the big corpus. Okay, so we went off and we learned this word rights or bill from the big corpus, Wikipedia. We're going to allow it to be a bit different in this sentence that we're looking at, but we're not going to allow it to be so different that it becomes overwhelmed by the averaging of words like the and of and so on and so forth. The reason this works is because that original embedding of the word bill or rights or whatever it is that you want to look up isn't so sensitive to a small number of function words, right? It wasn't formed by just taking a kind of a dumb average, right? It was formed by some very complicated model fitted to billions of words and so on. There's also some other stuff going on in that equation, which I didn't mention. So what we're doing also is we're weighting up certain words where we're more certain, but we also log it. So that avoids situations where we end up kind of producing great embeddings for function words and bad embeddings elsewhere. That's something that you can change, but I wanted to just focus on A to give a sense of the intuition about what's going on in this kind of fundamental equation. So why does any of this matter? What's the point, right? What was the point of doing all this? I want to emphasize exactly this slide because it's crucial to what we're doing next. If I can produce an embedding for any word, right, I can produce it for any instance of any word. Every time you say a word, okay, even if you say it multiple times in a speech, if you say it just 3 or 4 times in a lifetime or something like this, I can get an embedding for that particular instance of the use of that word. And that can in principle change a little bit from person to person. But then that means I can put everything in that multivariate regression setup. So now, every time you saw that word, in terms of it being used, I can get a slightly different, highly context-specific embedding for that word. That means I can then regress it on the groups. Well, now's the question, does it work? Let's find out, without using regression to start with, let's just find out with a kind of simple example where we know what the answer should be. So what we're going to do is look at the New York Times corpus, and I think we had, I can't remember the exact years we used, it's basically about the last 5 years, I think. And we're looking at mentions of lowercase t Trump and uppercase t Trump. So fairly obviously, uppercase t Trump is President Trump, right? Donald Trump. I mean, he was also, had other jobs he was doing, he was a property developer and so on. Lowercase t Trump is not him. And in particular, it's, being used as a verb or as a noun in a way that we'll come back to in a second. But the key thing is that when the New York Times talks about lowercase t Trump, it's talking about something else. So what we'd like to show, ideally, is that every single embedding of the lowercase t Trump looks like all the other embeddings of the lowercase t Trump, and that looks separate and different to embeddings of the uppercase t Trump. Okay. And we're going to take a look at how they look. So in this particular plot, we're going to put everything in 2 dimensions just because it makes it a bit easier to see. That doesn't mean the underlying embeddings were in 2 dimensions. It makes everything sort of simple. So this is the type of sentence that you would find in the New York Times, and we want to build an embedding of capital T Trump here based on the words around it. So it's like an average of, a weighted average of unflattering picture of President Trump, blah blah. Okay, and if we do that, what do we get? Okay, we get some particular embedding that in 2 dimensions sits here. in this space. All right, okay, so 5 American spectrum of President Trump. So, okay, so this was about President Trump, right? So let's get an embedding for it. Okay, just the single use of the word Trump, just sitting in an article somewhere based on Americans focused on it, so on and so forth. Where does it sit? Ah, it sits here. Oh, that's good. Looks like it sits near the other use of the word Trump. Oh, hang on. So here's a new use of the word Trump. This doesn't look like President Trump, but let's build an embedding for it, lowercase t Trump, and let's see where the machine puts it. Oh, okay. Puts it in a different part of the space. And we can just keep doing that, right? And we find that these two different understandings of the term Trump, admittedly sort of obviously different understandings of the word Trump, separate out very nicely in this space. So it's doing something right. It's getting these embeddings correct in terms of the two different groups. Correct in terms of the nearest neighbors. All right. So I just want you to look at the right-hand side of both columns. These are the transformed, so multiplying by this A matrix, right? And it seems that it is, right? So capital T Trump, we're getting the right kind of terms that seem to be sort of nearest neighbors for capital T Trump, and lowercase t Trump, that looks right as well. So it looks like it's from a card game, something like bridge, whist, something like this, right? We got some slightly strange nearest neighbors in there, like obeyed, but otherwise it looks about right. So then in the paper, we turn to a replication of this very nice paper by Emma Rodman. So in her paper, I'll move through it quickly because it's not our paper, it's her paper. So what she's doing in her paper is she's trying to get embeddings between a term like gender and the term equality. And she's using this to talk about the idea that the particular context in which gender is discussed in US news is changing over time. So maybe it's become more about gender equality than it was historically, or rather, to the extent that gender is discussed, right, maybe it's more connected to equality than it was historically. So she has a very high-end model. She uses a state-of-the-art chronological embedding in her work. And we get basically the same results as her. What we're showing here is if you look at these lines on the right-hand side, if you look at the ALC, it's very close to her model, which is the CHR, or her chosen model, which is the CHR. But the thing I would emphasize is that, well, so firstly, we think our nearest neighbors are better, but that's not, that's arguable. But the thing is, we replicate her results in a little under 1 second, right? So she takes about 5 hours to fit these models, and we can kind of replicate it in under 1 second just by doing this matrix multiply. So this is a very, very fast technique. So we've done all this, we've motivated the idea that these embeddings sort of seem to work, that this Trump versus Trump seems to kind of function, that we can do what other people have done very quickly, but we want to do more. So what we really want to do is compare people in two, maybe your 2, 3 different groups, or even have a continuous covariate. So without loss of generality, we'll suppose that there are 2 groups, and we have some group R and group D, and you can think of it as there are Republicans, and those who aren't Republicans are group D, but you can just think of that as R equals 0. So that's the problem. We've got this familiar embeddings equals, we want to predict it using the people's membership of group R or not. So just to recap, yi is a 1 by d dimensional vector, and that's going to be, as I said, this term, the ALC embedding, which is this idea of an average multiplied by a matrix, which either you get from us or that you fitted yourself. And R, for now at least, is just an indicator telling us which group the person is in. So what do we get out of this? I'm not going to belabor this mathematics very much. It's just working through the expectations operator. But what we're able to do is that we can show that from this equation, you've got these beta zeros and beta ones. Beta 0 turns out to be the embedding for group D, right? So the embedding for the case where Republican equals 0. Okay, it's the average embedding, in fact, for group D. So you can look at the mathematics here, but the essence of it is the expectation operator goes through, A comes out because what it's estimated, and then we get this hat. This is a kind of what is your embedding given you're in group D. So what's left? Well, beta 0 plus beta 1. These should really be estimates, but you know what I mean. This is the ALC embedding for group R, right? And again, to reiterate, these are average embeddings. So when we sent this paper off to get reviews, one of the things that referees said, completely correctly actually, was they said, but okay, but isn't this just a method of getting averages for different groups? And we said, yes, that's exactly what it does. So it's returning to very quickly an average embedding, or one of the things it can do is return an average embedding for each different group. So we can compare the magnitudes via the norm of beta. I won't spend too long on that, partly because we have some extra work we're doing in the software at the moment to make some improvements to that. But the idea basically is that you can think about, is this beta 0 different to beta 0 plus beta 1? Right, that's a magnitude you might want to estimate. And we can give uncertainty estimates using things like the jackknife. And if you want empirical p-values, we use permutation. I can go through how we do that, but the essence of it is we use these some tricks, some ideas from work by Taddy and others, where you write down the Y matrix and you shuffle the Y matrix and you use that as a null distribution, and you compare the distribution that you got relative to that null, and that you look at where the p-values, where the values are that you got in that distribution, and that becomes your p-value. We're actively working on that actually still, so we'll have some improved software out soon. Okay, just to give you some examples of in the paper what we do, we say, okay, well, there are these partisan differences in speech. So for example, things like immigration, marriage, and abortion are, I think, the most different, or some of the most different terms in terms of how Democrats and Republicans speak. You can do it for continuous covariates too. So for example, nominate scores, which is many Americanists use to estimate ideological position in the chamber. As we move from left, so over here on the left to the right, we see and we look at the cosine similarity with a word like immigration. We see that, for example, like a word like illegals, it's actually, I think, a stemmed version, there's lots of words in there, but it's, as we start out on the left, right, left Democrats hardly ever use it in conjunction with immigration. And by the time we get over to the right, the most conservative part of Congress, they are using it much more often. What about that empire example? Well, it turns out that if you look at the cosine between Brits and American legislators just after the Second World War in terms of their use of empire, it drops suddenly. So here it's dropping. So it's pretty high up here, and then something happens which makes the difference between their embeddings of empire be somewhat more different than they've been before. So it drops down and the mean is a bit lower afterwards. So how does it differ? Well, when you look at the words, we see that both countries start out talking about empire in basically the same way. They mean it in the sort of old European sense of places that typically European country has as colonies. So Australia, they're talking about French colonies, so on and so forth. By the 1950s, however, the US has a sort of new understanding of how it uses the word empire. And it uses it primarily and somewhat distinctively to refer to what's going on in the USSR. So sort of a communist empire, that Lithuania is now an imperial possession of Russia or something like this. Whereas in Britain, they're still using empire in the traditional sense. So one of the things we also look at is sort of, and we give some fitting procedures for this to generate auxiliary quantities, looking at kind of what are the most British and most American nearest neighbors for a word like empire. How are these legislators thinking about empire? So for example, in the American case, they're talking about Moscow and communists and Soviets. That's just a very American understanding of that term. Whereas the Brits are talking about Australia, Kingdom, Commonwealth, maybe not that surprising, these terms, but seem to suggest that, these are doing something useful. So the final worked substantive example I'm going to give you before moving to the extensions is this, and it'll take a little bit of time to build up, but hopefully it'll be worth it, is this case of thinking about sentiment. So political scientists are in general very interested in sentiment. That is to say, sort of your emotional affectation towards particular ideas. In this case, we're interested in affectation towards something like the EU. So if you are from a Westminster system, like Britain, New Zealand, Australia, Japan to a lesser extent, you will know that when power shifts, which is to say when Labour, say, goes from being in the opposition to the government, they suddenly start to sort of, they control all the policy of the government, and they start to talk about it in a much, more salubrious, happier way. So let me show you what I mean. Up here, we've got the cabinet, which is to say the ministers in Britain. And up until 2010, right, we have this dark line, the Conservatives, and they're talking about education, and they're very down on education. You might be thinking, oh, they're anti-education. No, what they're anti is the education policy of Labour. And the second they win power, they become very in favour of education. And again, what they're actually in favour of is their own policy. And Labour does the opposite, right? They're very in favour of this policy, and then they stop liking it. See the same pattern with the National Health Service in the UK. Down here, we've got the backbenchers. So backbenchers kind of a bit more enthusiastic about education. The sentiment goes up when they control it. It really goes up. They start talking about the NHS, very happy about it. But let's take a look at the European Union, and it's just a mess. It's really a weird topic. So what's happening? After the election, Conservative MPs who are in the leadership roles start to talk about the EU in a much more positive way than they've been talking about it before. So look at this break. So 2010, we see this kind of gradual increase in how the cabinet, it's much more enthusiastic about the EU than it was before. What about the backbenchers? No, it's really strange. So the backbenchers, unlike these other policies where we see this flip-flopping pattern, right, they're just always negative about the EU. They never really get behind the government on this policy matter. And in fact, the only time that this dark line starts to become sort of more positive and above the zero line about backbenchers is when David Cameron, who's the Prime Minister, announces a referendum around here. And suddenly the backbenchers become more interested. So it's an outlier, sort of decreases over time, and the rest increase. So a few questions you might have, and we might come back to them in the Q&A. So is the approach sensitive to decisions you make about implementation? Sure, yes. I mean, it's going to depend, right? We would say that there's not a lot of need to stop or stem the documents, though you can. And in some cases, we would suggest doing that because it'll speed things up. But of course, what you train on will matter. That's a big question we get all the time. Do I need to find a useful corpus, local corpus to pre-train on? Well, it depends. For modern English, something like Glove, which you can download in 2 minutes, is going to work fine. And we'll have some ideas in a second about what to do if you're not working in English. And then what about uncertainty in the estimation of A? Basically, don't worry about uncertainty estimation of A. We're correcting, there's a bias in, we and some other co-authors have noticed that there's a bias in the uncertainty estimation when the groups are very different sizes, but we're working on correcting that in the software, and so we think that will be helpful. So can it be expanded beyond English, you might be thinking, and the answer is yes, and we have actually a working paper about this. So we've expanded it to, well, about 40 languages actually, but the pipeline is there for 157 languages. We use a slightly different way of doing embeddings called fast text, which uses subword information. And we mean it for sort of two sets of people. So people who just don't have very large corpora, they find it very, very hard to build embeddings. We have some embeddings for you. People have very low computational resources, so maybe it's very costly to train models or something. Like it's kind of a pain to train these models. I mean, they don't take that long, but they can take a few days on a cluster using some, fair amount of space. The embeddings themselves aren't that large. They might be 40,000 to 100,000 words or something like this, matrix of 300, and then we also have the transformation matrix. But they're kind of annoying to train. So we train all of ours on Wikipedia. So these are the languages we've done. I won't get into these reconstruction plots, but suffice to say that they sort of work okay. And we think they're pretty useful. Let's maybe do some more interesting validation. So for example, when we compare, because we provide ALC versions of this, look at a word like racism in French, right? Our nearest neighbors are pretty good, or they're not bad at least. So that suggests that these embeddings work pretty well. We also roll them out to humans. So what we do is we ask crowd workers to tell us whether or not they're producing sort of plausible context terms. So we've done this for speakers of French, Arabic, Russian, Mandarin, Spanish, Korean, Japanese. And this covers a lot of languages ultimately in the world. And this is the type of question we give people. And they have to, which of these is a better context for this? And we obviously, you can imagine we do this thousands and thousands of times. Same for Russian. And what we find, at least in our experiments that we did, and they're a bit better than they were at the time we did them, but we find that generally ALC and fast text, ALC doesn't do as well as fast text, in fact, but that's okay for reasons I'll explain in a second. But if you compare things like our fast text to the original fast text, it's kind of indifferent. So we would recommend, using our fast text. And on the bottom down here, we have the words that we ask. So obviously we translate these into lots of languages. So all liberty, citizen, police, justice, law, tax, politics, equality. These are words that you might be interested in various languages. And then this is the summary on the left-hand side. So one thing we'll just say in passing is that ALC, although crowd workers don't always like it, one of the things it does is gives very, very context-sensitive terms. So something like a fast text, if you just download it today, for a word like law in Arabic, it will say things like legally and legal, which are reasonable nearest neighbors, but ours are much more specific. They're things like legislator, binding. So it sort of depends on what you want in terms of embeddings. So if you are, what should you do, right? If using our, transformation matrix and embeddings. So if you have a corpus like Wikipedia, then go ahead and use our transformation matrix. If you don't, and your data is very big, then just go ahead and fit your own embeddings. And if it's small, probably fit ours and then just validate that it works. So we have software. It looks like this. So if you've used something like R's, linear model or generalized linear model functions, then this will look familiar. I have some code actually in a second that we can look through if you like, but the essence of it is that I'll just talk through sort of what's going on with the function. So the core software is called context, and it's meant to remind you of the idea that you're, fitting a regression in the context of something else. So the formula is, say I want to know, and I want to be careful with my terms here, but sort of what is the effect of being Republican in terms of your embedding of immigration? Have some data, you tell it what it was pre-trained on, you tell it whether there's a transformation matrix or not. We can give you one, or you might have one that you fit yourself. All right, so in the old days, it had bootstraps. We've now changed those for permutations for various reasons. Jackknife equals true, so these functions run quite quickly. All right, so thank you very much. So if you want to read all about the paper and what we're up to, you can go to Embedding Regression. I won't do that now. And that will also take you to the software, which is called Context. Those are my co-authors. So Pedro was a PhD at NYU and is now in private industry. Brandon is a professor at Princeton, and Elisa is an excellent ABD student at NYU. And that's it for my talk. I'm very happy to take questions. I also have code if people want to see it, but I'm also very happy to whatever order people recommend.
Excellent. Some echo in my thing. Let me see if something to do with my machine. Can you hear me?
I've got you. Yep, I can hear you, no problem. Yep.
Okay. Now, I think we have about an hour or so, and let's do it this way, and let's open to either side to pose a question. We are open to asking question either in person or you can speak out, or you can type your question in the chat box. I can read it out to the speaker, and then we can also accommodate any technical request, and then we can use the second hour to address some Q&As and maybe some technical issues. And maybe I can get started if you do. Then let me take advantage of the position as a co-host, and I can take advantage and ask the first few questions. And this is really interesting work. And for your information, I also mentioned that this is a published article in APSR 2023, which is brand new. And I think let me first ask you the question about your the inspiration of this research design. I know that you tap into the embedding literature generally, then you want to apply to your research, particularly in political discourse and questions. What inspires you? And in the beginning, then you think you can start this project. And now I think it's coming to fruition. I think it's highly promising. It's the more to come. So what inspires you in the first place?
Yeah, I can be, there's a sort of, it's a very sort of direct technical answer, and there's this, more general answer. So one of the things that my co-author, Brandon Stewart, he's a very brilliant man, but he, one of the things that he co-invented was this idea of the structural topic model. And he invented that because he was, so he was thinking to himself, well, people always want to make comparisons of topics across people or across groups or whatever it might be. And so he came up with some ideas with some co-authors about how to do that. And one day I was working on an embedding problem, and I was thinking about, well, this is if we really believe that embeddings tell us something about meaning, wouldn't it be cool to say something about how this person's embeddings sort of differs from this other person's embeddings, or this group's embeddings from this other group's embeddings. And I was just always very interested in this idea. And now the way that we solve that problem is not the way that STM solves its problem. They use something else. But I was just always interested in that idea of trying to use the type of logic where you're trying to compare groups to say something interesting. But more philosophically, I'm very interested in how two different sets of people might talk about something in different ways. So I think a lot of, I've always been interested in this idea in the US of people talk about dog whistle politics, right? So this idea that you're communicating very subtly some sort of hidden meaning. Can we uncover that, right? So can we understand from the context that that's what people mean by this term or something like this? And that's sort of what got me, interested in sort of how terms change over time. And just a final sort of example of this is in the US, right? I've become very interested in people, particularly in academia in the US, right? They often might describe themselves as progressive. But when I was learning about the US, when I was a student, or in the US or outside, right, progressive was actually something completely different. It was a political movement, but it was from 100 years ago, and it was a completely different movement. It wasn't about really. It was about sort of public administration and standards and so on. And I just got interested in this idea of how the terms that we use change. So that's why.
Yeah. And allow me to have a follow-up question, because it's exactly what you mentioned about change. Meanwhile, I posted in the chat box the GitHub and also the paper on Cambridge University Press and APSR 2023. Now, you mentioned change. So when we learn data science and Texas data, we always talk about the Brown corpus. And then there is the British National, I think that's the full name is National English Corpus. So that is like the big corpus for us to tap into when we look at the language models and look at the text models. So there are a couple of things, and I think you are pointing us to think and research and a specific direction. For example, how this embedding evolves over time and over more generally big contest. As you mentioned about the British versus US, and but you
Yeah.
think about, and for example, in a more specific domain versus more general domain, for example, political studies or political text, such as congressional speech, and such as maybe newspaper. They could be still kind of like political discourses presented in different channels, but they could be leading to different different embedding and different distribution. In our sense, think about distribution. I'm thinking about distributions. So the big finding here, the big message you got us here is things are evolving and could be converging. It could be converging too, right? For example, you have examples so as the immigration could be, some could be
That's right.
just basically identical, but some could be, but over time and over some different domains, point us to understand the source of this departures or variance. So, and also the other way too, maybe we are converting to a same language and the same zero variance meaning, versus we are going maybe more easier word understanding. We're getting more polarized and looking at political polarization discourses, and then we can see that now we are headed this way or headed this way. So and you are starting us to think of this this way and change evolution of our language of our discourses.
Yeah, so it's a few responses to that. So yes, it's a very interesting question as to where these differences in understandings of meaning come from, especially in the political sphere. So I suppose it's that issues kind of come onto the agenda and they become politicized by parties. There's some entrepreneurial element to it. And so they just start to talk about them in different ways, some issue like immigration. But it must also be true, I think, that there are topics where the vocab closes, right? So it used to be very different how the sides talk about it, but now it's kind of agreed. So I think there are certain sort of social rights in the US, so civil rights in the US, maybe some gender rights in the United States, right? Over time, maybe the parties talked about it differently, but now they sort of talk about it in the same way, and indeed we don't talk about it. So one thing one thing we didn't really look at, and I think it's a very interesting question, is so our supposition, right, has been that, well, my supposition, I don't know about what Pedro and Brandon think, but is that to the extent that groups talk about things differently in a political context, it's presumably because the difference has been politicized, i.e. it's not just some regional difference, or it's not just like we just have this traditional different understanding of this term. It's presumably because these are the differences that they want to be politicized. Now, this isn't true like completely generally, right? So you can imagine that, say, different academic disciplines like machine learning or statistics might talk about bias differently or something, right? That's not because it's politicized, but but it's an interesting question as to whether everything that's left that we talk about differently between two different groups is politicized. So it's an interesting question.
All right, I think I will invite questions from the Taiwan side or maybe from the US side, and I think I saw a hand from Joan. Yan, do you want to pose a question or as I speak up the question? All right. Oh, so we have a hand from Jing, Chao Jing, and please go ahead. If you would like to speak up.
Hi, hello. I'm Jing Chao. I'm currently at the Southern Methodist University, and I happen to work on sentiment analysis myself too, online review data. I have two questions. One is pretty technical because you're using those neighboring words, try to give context-related embedding rather than those trained by GloVe. Because for GloVe, no matter where the word is, the word will always have the same embedding. So it's context independent. So the question is, what is the kind of how tight the neighborhood is? I mean, you give the examples like 2 words before the current word and 2 words after the current word. So what is the neighborhood? Is your kind of a matrix very sensitive to the neighborhood, or is it kind of robust?
Yep. No. Yeah. So it's a very good question. So what we do, for what it's worth, we tended to use a window of 6, which is to say symmetrically 6 words either side of the target. We did some experiments with other window sizes in the appendix of the paper online, at least I recall. And it doesn't make a huge difference to our inferences. I mean, there will be some differences. For what it's worth, the way the software is set up, you can choose your own window size. So if you want to fit your own ALC embeddings, you simply choose what window size you want. Now, the next question is, why did we choose 6? So we chose 6 because in our experience, and I have written another paper with Pedro about embeddings in general, it's very it's very generally commonly used, and so we wanted to, because it works, and so we wanted to use 6 in the original run of the paper. But for example, in the recently we have a renew sort of paper on this, or on the multi-language stuff, and I think we often use a window of 5 for that. But it's up to you. You can use whatever window you want if you want to fit your own embeddings.
Okay. Another question is more kind of on a general perspective. And then I think if my understanding is correct, is you want to generate context-dependent embedding. So the same word can mean different things in different contexts, and want to see how those contexts, semantic meaning evolve in different environments. If my understanding is this, but
that's right.
Another way to look at it is, I think Google has this attention mechanism, right? So attention in transformer. So what attention mechanism is very good at is to incorporate context into the interpretation, into its like embedding. We can use attention mechanism to generate context-specific, context-dependent embedding. So I'm wondering whether you have considered that, whether you have compared your model with this mechanism of generate context dependent embedding, and
So we haven't done many comparisons with transformer-based models, and including things like BERT. So the reason that we pursued, so firstly, if you have a different embedding that you want to put in the regression, that's fine. We are suggesting that ALC is a particular way to do it, and it's fast and needs very little expertise from the user. It's it's sort of very doable, basically. But the other reason we're doing it is because we want it to be sort of seamless into this regression framework. And so we have sort of worked this out for ALC. But if you had some different source of embeddings that you really like, that would be perfectly fine as a way to sort of push it into the regression. I think yes, we don't have any qualms about the idea that BERT embeddings are very good. I would just say that they need a lot of effort. Well, they can need a lot of effort to train. Even to fine tune can be a lot of effort, and we think what we're doing is simpler. But yeah, that's right.
Okay. Okay. Yeah, I will stop here and let other people ask questions. Thank you.
Sure.
Allow me to poke Peter, do you have questions from your side, from the students and scholars? And yeah.
There are a couple of questions from here, and okay, and I try to make sure that I interpret this questions correctly. One of this is that this trip in all right. Have you come across some researches that is done in Chinese Mandarin? Because you have performed multiple languages, and the my second question is related because that's a quite different language systems, and in terms of the grammar and all kind of structure of the sentences. So the question was like, does ALC perform well in terms of detecting things like sarcasm or some problem, and the questions about a sentence is the punctuation, especially in Chinese. The words, if there's no punctuation there, and then the context becomes very important, and then how well does it perform in terms of detecting the context, but without a good punctuation. That's two. I think they're related questions, right? Yeah.
So we haven't. Yes, we haven't looked at things like whether it can detect sarcasm or not. But that's a good question. Let me just on the Mandarin case, we do. So fast text, which is an outgrowth of, I guess at the time was Facebook Labs, produced. I think I had that right. It's not Google Labs. I think it's Facebook Labs. They produced embeddings for Mandarin, and we have produced ALC versions of those using the rules that fast text used, which is they have some particular, character distance. They embed these characters, and then they sort of take an average in this particular way. When we, the main way that we have validated those Mandarin embeddings, well, firstly, we had, Mandarin speakers among PhD students at NYU at the time, and they looked through and, they said, yeah, they're fine in terms of the nearest neighbors. We put them on the crowd, and they look fine. So that is to say, I mean, we're only doing a relative comparison of fast text versus, ALC or something. But people seem to think that, at least for the small numbers of cues that we did, which are things like politics, equality, law, police, tax, so on, at least for them, the Mandarin nearest neighbors from the embeddings looked fine. But if people want to grab those embeddings, they're very welcome to do so. In fact, I'm not sure if you can see that on your screen, maybe you can't, but I'll just show you where they are. I'll send you the link. Okay, I can put it down here in the chat. That's the website for our embedding resources. And Mandarin, if you click on the data and then you go to data and then download, you can get Mandarin resources there, and we'd be very happy to hear from anyone in terms of how they use those and how well they work. But people are very welcome to check them out. Yeah.
This is neat. Yeah. Okay, cool.
Let's invite more questions from either side.
Let's open up to more questions from anyone, and please feel free to do that. And we have a feature called Q&A, but anyways, that we can do that. Create pose a questions or do it in text. And yeah, I think I'm checking into the GitHub ALC embeddings org, and also
that's right.
Yeah. And also I posted Dr. Sperling's been mentioning about the fast text from Facebook research, and hope you find this useful too. All right, and any more questions from either side or anyone?
I can move to doing a little bit of code if people are interested, just for a few minutes. If people want to see how the code works, very happy to do that.
That's fantastic.
Okay,
I want to see
sure.
it in action.
Okay,
I want to see it in action. Then I can ask more questions. Then
that'd be great.
Try and do a share. If I do, Okay, yeah, so hopefully you can see my screen. This is what the code looks like. Great. All right, folks, this is just sort of practice code that you would get from the like context software site. So I'll just talk through what's going on here. So just for what it's worth, I'm using R 4.3.1. So let's try and okay, so we'll just set the seed here, and there we go. So I'm going to load some packages, and I'll just talk through them for those not familiar. So we didn't write these bottom three. So Quantita is a product from Ken Benoit et al., big team working on text, very nice text package. dplyr is a sort of tidyverse thing for managing data. Text2Vec, I think actually I'm not going to use today, but is a very nice package for getting embeddings. But this is the package that we wrote. It's called Context. It's on CRAN, so it's on the central R repository. I'm actually using right here, I'm using the most recent kind of beta version, which is not yet on CRAN, but is maintained on my co-author's website, on his GitHub, sorry. But as you can see, it's loading okay and so on. So what we're going to do in this very short demonstration, we're going to have a sample corpus, and it's this one, and as far as I remember, it comes preloaded with the there you go. So it's 400 documents, and it's basically people talking in Congress. Okay, so we're going to do some really basic, just Quantita stuff with this. We're first going to tokenize it. For those who are interested, what we're doing is we're just removing punctuation, getting rid of symbols, removing numbers, that type of thing. Then just for today, we're going to clear out a bunch of stop words. In principle, you can you can build up embeddings from the stop words. If you do the matrix properly, it should work, but we're just going to take the stop words out. So stop words are just function words like and, of, the, so on and so forth. Then I'm just going to, again, just for the demonstration today, to speed things up, we're going to only include things that occur at least 5 times in the corpus. So this is just, again, we're just sort of thinning down the problem. Now, this next point is a little bit more important. Sorry, I'm just going to put that down to the bottom. We're going to just select, it's a bit subtle, we're going to select the words. We're going to have these words being represented, but we're now going to know what context they're in, so what words they're next to. So this term here, padding equals true, just tells the words to stay separate. So I'll show you what I mean. So if I put in stop features, here are all my documents now. So President Rise today, Honor 1, Great Leaders, and you can see that it's changed a little bit from what it was originally. We just, So the idea in any case is that you can imagine that sort of here is the term president, here is the term president, president, right? And we might want to build an embedding word like president, across these speeches. So we're actually going to try and build some embeddings for immigration, or rather the way that various words that are associated with immigration are used in this particular corpus. So we're just going to grab them here. So I just want to show you, there's this little pattern here. It's just saying to R, give me anything that starts with IMM, IGR, and then star, anything comes after that. And so this is what you get. So they talk about immigrant a lot, they talk about immigrants a lot, they talk about immigration a lot, and we're going to build some sort of embedding for all these terms. So we're going to build a document feature matrix. This is just exactly what you, yes, exactly. So this is just what you'd expect. Yeah. So we're saying like, okay, in text 1, it mentioned institutions once, moral once, stood, so on and so forth. All right. So now sort of into the action. So first things first, we're going to tell it to produce a new type of object that's somewhat unique to our package, which is called a document embedding matrix. So this is saying, take that DFM, that document feature matrix, and then produce basically embeddings for every time the word immigrant, what was it, immigrants, immigration was used. So I'll let me just run that, but I'll show you what's actually going on. So we're saying, well, make sure you use a transformation matrix. So what is a transformation matrix? It's what we said it was. It's some little some big matrix we learned. So what size is that, right? And this should be d by d. So that's to say that it's 300 by 300. So this is that matrix that we're talking about that we're going to multiply by the averages to get good embeddings. Okay, so we're almost there. We're sort of gradually, now we're going to take the average by party. So just to explain exactly what we're doing here, we're saying, let me show you what this object is, because it's a bit strange, but you'll see why it's powerful in a second. So what we're saying here is that give me back an average embedding for all the Democrats, which is to say every time a Democrat mentions the word immigration, immigrants, give me an embedding for all those Democrats and take the average of it. So just literally take the mean of it. And then the same for the Republicans. So as it is over here on the left-hand side, that doesn't look very interesting, right? It's just some numbers, it's just some embeddings. Where it becomes more interesting is when we start to get nearest neighbors. So for example, we can say for Democrats, so I'll show you what I mean. So if we just take, here's the Democratic embedding. We can say this is the embedding for Democrats of the word immigration or immigrant, I guess. And give me back now the words, the embeddings that are closest to this vector in the corpus. And let's just find out what they are. So let's source that. Okay. What were they for Democrats? Okay, so they were immigration, immigrant, illegal, broken, undocumented. So it's Democrats talking about how the system is broken and, What about Republicans? How do they talk about it? Okay, well, they talk about it as being illegally. They're very worried about an amnesty, something like this. And maybe we can, increase the number of nearest neighbors, which run it again, to get a sort of richer sense of how the different groups are talking about it. So Republicans are talking about it in terms of aliens, borders, broken, criminal, so on and so forth. Whereas Democrats are talking about it in terms of amnesty, citizenship, act, dream. This was this famous act about the Dream Act was this famous case where it was a path of citizenship for people who came to the US as children. All right, so let's try to produce, maybe a more helpful graphic. So a bit like, the empire graphic we produced. Here we're looking at the nearest neighbor ratio. So what this means is, instead of asking, literally what are the nearest neighbors, because it's not that weird that we would share nearest neighbors. So if I talk about immigrant a lot, I'm sure I probably do it in the, in the context of immigration, as does the Republicans. So what we might want to do instead is ask, in some sense, how do these words differ from these? Like, what are the way that they differ the most, if you see what I mean, right? So we take the ratio of the differences. So let me do that. It's just going to take a second while it bootstraps through it. It's doing some shuffling to make sure that we can make correct inferences, because it's going to do it's going to generate a p-value in a minute. So just let it do that. And then we'll just plot it, and hopefully, I hope you'll be able to, in fact, I might have to do this. So let's just see if I can plot it. Will it work? Yeah, there you go. Okay, good. So it's telling you that the most kind of Republican words, right, like they just use them sort of so much more than Democrats do, are enforce, illegal, illegally. There are these words that kind of both sides use, so laws, legal, border, so on. And then there are words which is very, very democratic, how they use them: undocumented, comprehensive reform, broken, immigrant. This kind of makes sense, but still sort of helpful to get a bit of a sense of how these different parties, use these terms about immigration. So finally, we can do this immigration regression. And a nice feature of this is that, as you can see over here, we can actually have multiple words in there. We can have, immigrant, whatever, immigration, immigrant. And well, here's model one. It's just going to take a second to do. And it's telling us that Republicans are just have a different embedding to Democrats, and men have a different embedding to women, to very small p-values. And maybe, we might want to be a bit more precise about those p-values. So we just increase the number of permutations. Maybe we can change the confidence level to 0.99. We're doing a jackknife. Okay, so let's take a little while, but let's see. These are very different. The way we set the problem up, these are very different, but it will take a couple of seconds to, there we go. So we see that the estimates, don't really move very much. They move a little bit, but p-values are basically the same. But that's kind of how the software works, and that's the sort of thing that that people do with it. Let me return them here. Okay, good.
This is very interesting. That that plot ratio function is coming from a context package, right?
That's right. It's just taking the rate. Basically, the essence of what it's doing is saying, let's think about this: the nearest neighbors of this group versus the nearest neighbors of that group. Where are the places where they're most different? So you and I might both use something like immigrant in relation to immigration or illegal or something. Just occasionally we use it. But if you use it much more than I do, right, then that will be very, very high in your group relative to me. And it's just a way of sort of thinking about, because the problem with just looking at lists of nearest neighbors is we often have very, very similar nearest neighbors, basically, because we're kind of forced to talk about it in the same context. But when you look at the ratios, it often is sort of more informative.
So now I'm thinking about this is not you not only looking at the right hand side at the embedding, but more importantly, you also look at the variance across this, and then you can see that how much we are looking at different discourses, diverging versus converging, and the immigrant or IMIG is a really good example, and particularly, of course, in the current administration and the current Congress. And now that means that they open that the sky is the limit as to get us to, for example, look at some keywords. Now we can see the sources of polarization, and of course, I'm thinking out loud about how much we can see the embedding is projecting to our differences or the source of differences, but then also could be areas that we can converge into. So so this is I think this is really providing a lot of applications, and it just stop at how much you're creative and you can do anything. Now, before I entertain or introduce another question from the audience, I want to know that what if, say, this could be used to build another brown kind of corpus, but this corpus will carry more characteristics, particularly like what are diverging, what are converging, and over different time. So we can also take a look at it maybe across different administration, different Senate, and different House terms. So that will be something really interesting. We can see that and how things are moving, and we have a lane model. We know the things are moving. For example, China, and in the last 10 years, or globalization is moving. So this will be opening up more data, more ways of understanding this, and then we can do much more with because of the fact that text data is everywhere, and we can get the speech data and the Wikipedia data, the social media data, and also the Google search data, all kinds of data. We can now, that is really interesting application here. Now we can use this software to do much more, and maybe I can poke into your brain today. What is our next project using this direction? I think there's so many different options we can develop. What is the next project here?
Well, that's very kind. I mean, I don't really. I'm working on some problems in embedding, so I'm very interested actually in whether we can use them to sort of say a bit more about sort of intellectual history. So with a co-author at NYU, right, I'd like to know, we're working on this problem of the levelers. They're this 17th century radical group, and they're in favor of equality just after the English Civil War in the 1640s. And they kind of exist for 2 years, and they sort of disappear off the face of the earth, basically. They're arrested and so on. But one of the questions that I've always been very interested in political theory is, when we talk about, Locke, and we say, or Mill, Mill says, oh, he's interested in liberty. Or Marx says, this is what we mean by class, or something like this, right? So what does it mean for us in sort of quantitative methodology? How do we understand those problems? And so with a co-author, I've been looking at, what the levelers understood. The particular interest we have is what a particular subset of the levelers understood by the term equal. So there is this idea that, in the 17th century, that these folks were in favor of equality. So to the extent that they were, they certainly weren't very interested in, say, gender equality, right? And it's not really clear if they're talking about social equality, because this is pre-industrial, so it's not like a Marxist sense of equality. But they seem to be, they talk about equality, and so we got embeddings for equality and so on. But what makes it a little bit interesting methodologically or sort of technically is that you cannot, in general, just use modern English to build the embeddings. You need to fit it for the purpose. So we had to get a bunch of someone lent us some, but it was some parliamentary speeches from the 17th century, and then also the original kind of corpus of the levelers to do these comparisons. So I just found that an interesting technical problem. So I'm interested in sort of bringing these ideas, and again, it wouldn't have to be just ALC embeddings. It could be BERT embeddings, anything really, LLMs. To try and help people understand what people meant by certain terms. I think it's just a very interesting topic.
All right. Can we invite more questions? And otherwise, I would take advantage of the host, and I have 10 more questions. I think I do not want to take the whole night, and it's quite late in Princeton. And anyone would like to pose a question?
Yeah, so if you don't mind, I will do it. I don't do research.
Go ahead.
Yeah, I don't do research on Texas data yet, but I used to be a linguist, so I'm fascinated by what we can do analyzing the language. Yeah, so your targets so far have been just single words. What happens if you expand the target to a phrase? In some contexts, we do want to know the meaning of a phrase.
Yep.
So when I say what happens, I wonder if your software still does this analysis, if the uncertainty around it increases, anything else that maybe you can share?
Yeah, so you can use it. You can build embeddings for phrases. It can be done. It becomes trickier, right, when the phrase, if it's simple like bigram or trigram, you can just treat it as just another token, and you could build an embedding for it. Like if you think about a phrase like colloquially, some phrase about pulling my leg, meaning this person is joking with me. So pulling my leg, right? You could just treat that as a trigram, and we could try to then just replace it as a token, see the situations in which it occurs, and then build up an embedding from there. Obviously, it becomes harder with phrases because the way that the phrase is used isn't always exactly the same, and so they go through a lot, as you all know, like a lot of transformation over time, and they miss parts out, and memes miss parts out and things. But nonetheless, right, I think the general idea of looking at embeddings of phrases is sort of a good plan. And maybe it's something one could do. You could think about what a phrase is just, well, I'm sort of speculating here, but sort of a phrase is just the average of the embeddings within it. And so, you could maybe think about it that way. But I agree with you. And I mean, indeed, one of the slightly tricky holdups with looking at some of this philosophical stuff is that you're trying to build embeddings. Philosophers get very interested in something that maybe literally has been said once, right? So either, I don't know, Engels makes some throwaway comment about something, or in these leveler corpuses, corpora, the lead speaker will say something like, peers and equals, but he maybe says it once or twice, like that's it. And that's actually very hard to put an embedding for, right? You can do it, but it's hard to know what to compare it to, and but yes, I think it's a very good next step, and we would be very interested, yeah.
Mm-hmm. And so as a similar question, but it's still a different question, is trying to come up with embeddings for verbs, not phrases, but verbs themselves. Mm-hmm. I think that will be much trickier than doing it for nouns. For nouns, yep, you kind of know the syntactic environment. For verbs, I think there will be much more uncertainty in trying to come up with embeddings for verbs. But if we're thinking of political discourse, we are interested in verbs, like what it means to protect the nation, to like defend yourself from somebody. So a lot of things can be elicited from how we use verbs that are interesting.
Yeah, so two comments about that. So the first is, of course, verbs are in general more challenging because you have to immediately decide what to do about the affixes, affixes, right? So you'll say, oh, well, do I want to merge swim and swimming and, like all this sort of stuff, right? Because in some ways, politics may treat each of them differently. Like this is less of an issue with nouns, although, I mean, when we often put together some sort of compound embedding for like immigrant and immigrants or something like this, we think that's sort of fine. But yeah, I agree, verbs is harder and probably needs a bit more. No, sorry. What I think is very hard about verbs is that I don't think it's so that you know it when you see it when you look at the results. I think that's tricky. So if you observe, like when you look at something like abortion or taxation or something, I sort of know how I expect the congressional parties to be different on this. But on a verb, it seems trickier and more like it's sort of less directly about. It's one step removed from like direct retail politics of what they're pitching. That's what I think. Yeah. It's coding, right? It's like, oh, it's right or left coded. Yeah.
Well, thank you so much. I have the chance.
Oh, very welcome.
Thank you. This is fascinating, and congratulations on the publication. Awesome.
Oh, sure. Thank you.
All right. Do we have more questions for Dr. Sperling? Maybe again, go back to the logistic question again. Is it possible we can get your codes so we can? I think it's up to you then, and also your co-authors to see whether we can disseminate the sample codes you just demo to us. Yeah.
Yes, you can.
Or we can look directly in the GitHub of context, and maybe that would be another thing.
Yeah. So I'm just sharing it now, and so this is basically it's very neatly set up by my co-author. So I just did a version of the quick start guide here.
Okay.
And it just goes through sort of how to set it up, how it works. This is and then how to build your own embeddings. I did a sort of just a shorter version of this. But this is Drove stuff, and it's very nice actually. And I think he did the same example as me. Yeah, did he get the same coefficients? Maybe. Yeah, basically. Then he's describing how to sort of build the embeddings and sort of various other things, how to estimate the transformation matrix. So he's also explaining, like, on your, if you have a personal corpus, how to do it. There is also some.
That's really thorough. I check in the GitHub, also that. Yeah.
And then there's code here for the multiple one, for the other languages, if you need those as well.
Well, that's everything. That's interesting. This, yeah, we appreciate it. We appreciate your generosity in sharing everything, and also well documented and well explained. And so, are you going to maybe write a workshop, or maybe give a workshop, and and your team, maybe in future we can even invite you or your co-authors to give a workshop? That would be great, and maybe a short course, and that would be something gracious.
Yeah, sure. Yeah, I've taught many short courses on text. I think I wonder now at my advanced age if my best teaching is behind me, but I'm very happy to. I'm very happy to be part of it. Brandon, my colleague Brandon, and Pedro and Elisa also are very, very good at code. They spend all their life building packages, and well, a key thing about building packages actually is building a package is easy, optimizing it is very hard. So they spend a lot of time thinking about how to speed things up. And
Yes.
I'm always impressed with how much extra speed up they can get out of my code, basically. Yes, I think we're actually, it's a very active, we're actively revising, as I say, some of this standard error calculation at the moment. So that will all be in the package soon. I mean, it's a very, it's interesting. People, when you put things on GitHub, people send you ideas and things, and you can like incorporate them straight away. So we're very welcome. If people have comments about the package or what they'd like to do with it, we're very, very happy to hear them. Yeah.
Yep. Great, gracious. All right, Peter, do you have any questions or any suggestions from the side? Yeah, go ahead.
Just a general one, not technical one. The question is that Dr. Sperling, could you give the audience, especially other students, some advice on some general principles of framing research questions if they are to apply these methods? For example, is it pertinent to target concepts that are like competing or even controversial from different perspectives when the words or phrases are used? So some general principles like that.
Yeah, so I think so. I'm a big fan. I mean, I do methodology, but my basic when I'm reviewing articles, which I review quite a lot a year, I guess these days. I think about I'm asking myself constantly, is this helpful, and to whom is it helpful for? So helpful doesn't have to be a technical matter. It doesn't have to be that this solves a standard error problem or something like that. It can also be that this is helpful for scholars of this subject, and it helps to open things up. So often when I write reviews, I know maybe that's the way to think about it, and I'm writing a review, for a journal, I think to myself, who is this helpful for? Who is going to get something out of this? And when I write my own papers, I try to think about what would be helpful to the field. And sometimes I was saying to a relatively young scholar the other day, a postdoc actually, I was saying that a lot of good papers come out of people finally being clear about things that other people already not believed were true, but suspected were true, but they hadn't had time to show it yet. So I'll give just as an example, a colleague here asked a minute ago about it's probably hard to do with verbs. So yes, it's a very interesting question, but I don't know. And so, but that's the kind of thing that'd be very helpful for someone to look into, right? You just look into whether it's true or not, under what circumstances it's true. We already suspect it must be true, but just telling people more systematically and formally that this idea is correct, I think is a very, very good way to write papers. I don't think you need to be. I don't think you need to be controversial. Actually, I think often saying things which are, fundamentally uncontroversial is fine, Yeah, but as long as it's helping the field, move forward, so we don't have to think about that anymore, or we just have a lot of evidence now that that's true. I think that's sort of how I think about writing papers. And in my early career, I did a lot of work on. I was mostly doing substantive work about institutions, which I found it's very hard. It's hard to do. It's hard to get in the journals. And I've more recently moved to sort of trying to say much broader things about the discipline. The other thing that I would advise sort of younger people to do is you need to. I don't say you need to. It's not pejorative advice. It's that you. You sort of have to. You have to. Research is about specialization, but you sort of want to keep the contribution as general as possible. And that's just very tough to do, I think. You need to work on things that you find interesting, that's true, but it's that will keep I think, the idea more general. But you also have to sort of work on things that you care about for some other reason. And I'll give a very specific example of this. So I work on large language models, and one thing I wouldn't say I'm passionate about it, but I'm very interested in general, is the importance of open source large language models. So I'm very concerned in general that the world is going to be taken over and science is going to be taken over by people just running, tests through like ChatGPT, which not everyone can afford, or you can't get the underlying guts of the functions and all this, right? So when I write papers now, I try to think, okay, so I try to do two things. First is sort of say something interesting about large language models, which I don't always manage to do, but also at the same time, sort of have another agenda, which is that I'm trying to push this idea of open science and open source in this particular arena. And I think if you can combine those two, that's a very good feeling. I don't often manage it, to be honest, but that's what I try to do, yeah.
Gracious. All right. I think it's getting a little bit late in Princeton now, and shall we wrap up? And if you still have maybe additional questions, and please type up, and we can just forward to Dr. Sperling. And the materials, I think, is quite informative here already, provided by Dr. Sperling, and also the couple of websites and the GitHubs. And the paper is also available here. And so I think this is a really, really highly intensive and also informative talk and section. And I think I learned a lot myself. And I hope this will be also inspirational to the young scholars, young researchers, and young social scientists or political scientists. And please do not stop here, and we will be getting more in the series. And next week we have another scholar giving another talk. And all right, Peter, do you have more questions before we let Dr. Sperling go?
Yes, I just want to say thank you. This is really informative, like Carl just said, and especially for the Texas data. And this thing is really interests us, and most of our students, they're very interested in this this way of method. So I think they're gonna dig deeper into it. And so given time, if there's some questions, I'm hoping that we send you questions and contact you, and then you can give us some suggestion or advices.
Very happy to. Very happy to help.
Yeah.
All right. Okay.
Thanks.
All right, I want to thank you all and say good night to Dr. Sperling, our great speaker, and also this is going to the afternoon in Taichung. Okay, I want to conclude here. Please do not stop here. Join us next week for another talk, and our website giving more detail about the whole series. And please register. If some of you encounter problem about registration, please let me know, and there could be something on our team side. And otherwise, I want to say good night and a good rest of the day for all the audience. Thank you all for joining us. Thank you.
Yeah.
Thank you. Good night.
Yeah.
Thank you. Thank you, Dr. Sperling. Yeah.
Bye, everyone. Thank you, Dr. Ho.
Oh, great. All right.